Hi folks, we're going to take a look at number 14 on page 302. So they want us to solve this equation here. Now the original question was on 0 to 2 pi. I changed it to 0 to 4 pi. Okay, so at this point here, there's not too much to do because you've got the same trig ratio going on throughout the equation. And hopefully you notice that this is a quadratic trigonometric equation. So just treat this as a regular trinomial and try to factor the left-hand side. So now what's nice here is that I've got prime numbers in my leading and constant coefficient spots. So I know that my first two terms, or my two first terms, have to be 2 sine x and sine x in order to get 2 sine x squared. And I have to have 1 times 1 to get the 1. It's just a matter of determining the signs in between. And so here I need -3. So this is going to be -2 minus 1, -3, and so equal to 0. And that's a pretty easy factorization. So now either of these can be equal to 0. So from the first one, I get that sine x can be equal to half, which does relate to a special angle. And here the other option is that sine x is equal to 1, which again relates to special angles. Okay, so let's start with this one here. Let's find our two values in the first cycle that give us 1/2. So x is going to be equal to, now again, this is y over r. So you got to be thinking the y value is the smaller one. So that's going to be pi over 6. And of course, it's also going to be equal to 1/2 in the second quadrant. So 5 pi over 6. So there's our first two answers. But of course, we have more. Because this goes beyond 2 pi. So I'm just going to add the period, which in this case here, there's no k value, so it means the period is 2 pi. So I'm going to add to these 12 pi over 6, which is equivalent to 2 pi. So here this is going to be 13 pi over 6, and 5 plus 12 is going to be 17 pi over 6. And so there we have it. We have all the solutions. Again, if I try to add another 2 pi, I'm going to go beyond 4 pi here. So those are all my solutions from the first equation. Okay, now sine x equaling 1, that's, one of those scenarios which is going to be on the axes. And there's actually only one answer in the first turnaround. Okay, and that's going to occur at pi over 2, because here you have the point 0, 1 and a radius of 1. And so y over r just gives me 1. So that occurs at pi over 2. And that's the only time in the first cycle. But of course, since we're going up to 4 pi, we can add 2 pi to that to get to the next one in the next cycle. So, so add 2 pi is like adding 4 pi over 2. So that's going to be 5 pi over 2. And that's going to be all our solutions. Okay, so just to quick recap here. So quadratic, meaning you're going to try to factor, which we were able to do. And in the end, the two equations that resulted from that both related to special angles on the Cartesian plane. Okay, that's it for this one.